Hello everyone, this is Aniket Amdekar and welcome to the part 2 of the Analyzing Wireshark Logs video. In this video, we will take a look at how do we analyze the packet captures that we take from the network. We will also be looking at how do we document the analysis of a capture file. Okay, let's open up a capture file that was opened before. Now you can see in the interface you can see that if you have ever opened any capture files before, you will be able to see their reference as a recent file that was opened. So I'll click on open and we'll choose one of the files. Okay. One of the advantages of using the latest version of Wireshark, that is 1.4.1, is that it opens up the capture files very quickly. So in earlier versions, if the size of the capture file was very big, then it used to take a long time for opening up the file, which is and in the latest version, that particular issue has been taken care of. The screen is divided into three sections. Section 1 is the packet list. When you highlight a packet, you will be able to see the header information for that packet, and the header information will be from the physical layer to the data link layer, network layer, uh, to the transport layer, and in the end you will see the data. So if you expand each and every section, you will be able to see the various options. For example, you can see the source MAC address, the destination MAC address, and if you expand that, you will be able to see more details regarding that as well. If you expand the IP section, then you can see the version number. This is the IP header we are looking at. So all the options that are present in an IP header, you will be able to see them here. And when you highlight any information in the header, you will be able to see the byte-wise information in the third section of the screen. So these are the three sections: packet list, header information, and byte data. You can see when I highlight a part of the data, it will be highlighted in the header as well, and it goes otherwise. So if I highlight a part of the header, it will be highlighted in the data part as well. You can see that each and every packets are colored in a different way. This is because of the coloring rules. So if you click on view and then you click on coloring rules, you can set the rules as to how do you want them to look at, how do you want your packets to look. So if there is a TCP reset, which means it's a bad packet and we are coloring it as red. HTTP will be colored as green. So similarly, you can choose how do you want to color the packets. So if you have set up custom coloring rules, you can always export them, so you can save them on your computer, and you can import them in the future as well on a different computer. Now we'll take a look at how to see the summary of a capture file and how it can be useful to you in analysis of the capture file. For looking at the summary of the capture file, go to statistics and click on summary. You can see that you will see the name of the file, what is the length of the capture, what was the packet size limit. You can see here the timestamp of capturing the first packet and the timestamp for capturing the last packet. That will give you for how long this capture was running. If you are using any display filters, in that case you can see those over here as well. The most important thing you need to know in a capture is how much data was transferred while the capture was running. So if you check out the bytes section of this summary window, you can see the amount of bytes that were transferred in this transaction when the capture was running. You can also take a look at the transfer rate. So if you are troubleshooting network delays or network anomalies, this is going to be very helpful. So while documenting your analysis, you can always begin with the raw file that you have received. What is the size of it? For how long Wireshark was running? how many bytes were transferred during that time, and what was the transfer rate. And as a proof of concept, you can always provide a screenshot of the summary file as well. Now we will take a look at how to prepare a filter. A filter is a display filter we are talking about over here. A display filter will help you to bring out the most relevant packets in this capture file that will help you to investigate what happened during this transaction. Either you can use the predefined filters that you already know. For example, if I type in HTTP, I'll be able to only the packets with the protocol name as HTTP. As you can see here, we have the packets with only the HTTP traffic. Now if I take a look at the summary section, we can see that the captured number of packets and the displayed number of packets are different. Also, you can see the difference in the data that was transferred. You can see that the display filter has been provided as well. So either you can use the filters that you already know, or you can build up the filters as as you see important things in these packets. So for example, I come to know that 10.60.200.63 is the server and 172.16.1.61 is the client. If I want to see the traffic between only these two IP addresses, then I will need to prepare a filter according to that. So we'll right click on the IP address number one. That is, we'll do a right click. We'll go apply as a filter and select it. Now you can see that in the display filter, you can see it is mentioned as IP.source equal to IP address. But we want the traffic that was sent to and that was coming from this IP address. Hence, we'll modify filter a little bit and we'll make it IP.addr. Now we have the traffic that was coming from or it was going to this IP address .63. Now we want the packets where these two IP addresses will be present, that is 172.16.1.61. So I will right click on this IP address. I will go to prepare a filter and I will choose and selected. So this will mean that my existing filter and the selected field will be used as a combined filter. Again, we'll modify the filter to suit our needs. You can see that Wireshark is automatically completing my filters. I just typed in A and it has started with ADDR. That is the first match that was found to the letter A. So I will hit enter. Now we have the traffic that was captured between these two IP addresses. If you want to save this particular traffic, you can go to File, go to Save As. Now you have the option of saving the captured packets, displayed packets. If you choose displayed packets, then you are saving a much more relevant traffic that was important to your investigation. So I will say that output 1 and I will save it. Now I have used this filter for generating output 1.pcap. I must save this filter in my analysis because in any investigation report you should provide data or you should provide evidence that can be applied to the raw file that was given to you and that will generate the exact same results that will be used for analysis. Hence, since you have the raw file with you, now you will save the filter that you have prepared along with the information that you had wrote down earlier in your report. So that will help you to generate the file that is output1.pcap. Now we'll close this file and we'll open up output.pcap. I'll put 1.pgap. Okay. Now this is a much more relevant traffic that we have here. One more important feature that you should know about is that in the new version of Wireshark, that is 1.4.1 that we are using, you can provide custom column names. So for your investigation, suppose for your investigation the header length of a packet is very important, and you want to take a look at any variations from 20 bytes. What you can do is you can right click on header length and you can choose the option that is apply as a column. Now you can see that header length has been added as a column in the packet list. So if there were any packets where the header length was something different than 20, and you can always sort the columns according to the column names. So now we have sorted columns in the ascending order. So if there were any variations to this header length, so you can know about it. Okay, now you can see we have some bad traffic here. A lot of black packets, and you can see the change in the header length. So you can see that this is a duplicate acknowledgement for the packet number 31159. If you highlight that packet, the important information, now you have highlighted the information part of this packet, so that part will be highlighted in the header details as well. You can see it is highlighted as blue in the TCP section. If I expand this, I can see that this was a duplicate to the acknowledgement in frame number 31159. You also have an option to choose this as a filter. Apply as a filter selected. So if you do that, this will help you to build up a new filter where you can see the duplicate acknowledgement to the frames. Now these are the specific packets that were used as duplicate acknowledgement frames. So you can examine and investigate them separately. So this is how you can drill down to more details of a capture file to bring out the most relevant information that will help you with your investigation. The next thing that we are going to take a look at is expert information. Suppose that we have opened up this file. You need to go to Analyze and then click on Expert Info Composite. That will help you to see what kind of traffic you are seeing over here. You can see there were two packets where there was a malformed HTTP packet that was received, and when you highlight these packets, when you highlight this information, the individual packets will be highlighted in the background so you can analyze them individually. There were four packets with the warning sign because there were some out of order segments, there were fast retransmissions. So now these are all network related issues that you can investigate. You can see that there were 248 packets with out of order segment. So if you see a sudden rise in these kind of packets, then you can come to know that there is something wrong with the network. Now these are the nodes that is the duplicate acknowledgements.